Hello and welcome back to another episode of K-Tools, this add-on development series. And what we're going to do in this one is create the boolean operation. So I just duplicated this mesh here, and I'll go to the modifiers, add in a boolean, and we're just going to look at what I need to automate here. So I'll select this object, and you can see in this outline here that it has cut the object. And what we'd like to do now is actually have the cutter object, the boolean object, go to viewport display and set it to wireframe. Another small convenience would be to add a collection, call it booleans for example, and then maybe even change the color to red if we'd like, and then assign that boolean object to that collection. That way you could toggle the collection off and you don't have to see that stuff anymore. Another option that we could add is to parent this cube. So there we go. Now it'd be parented. And then to top it off, it would be nice if it was assigned to hotkeys. Control minus, control plus, and control backslash. Alright, so let's take a look at how to do this. So I'm going to go to operators and just create a new operator. This one's going to be called booleans.py. And we'll go to mirror and just copy the things that are in mirror here and paste it in. Next, I'll just go ahead and get rid of this stuff in layout. I'll delete all of this and execute. And our poll method is going to be a little different this time, so I'll just say return true for this moment. And let's see, we'll just go ahead and name everything the way it needs to be named. So instead of mirror, we'll just say boolean. And kt mirror, we'll just update all these names real quick. Boolean, boolean, there we go. And for the axis options, we're going to change this to boolean options. And we'll pass that to items, and we'll change this to booleans, and we'll change this to boolean type. So we got boolean options being passed in, and the three types that we're going to do is difference. Make sure I spell it right. Difference. I think I spelled it right. Let's see. Difference. My spelling is not the best. All right, there we go. I think that's it. And then there's going to be union, and then also there's going to be intersect. Oh, intersect, like that. All right, just add a little spacing here. Alright, and now I'm just going to make sure we set the default, and I'm going to set it to difference for the default. And now let's just make sure we register this. So I'll actually do it in alphabetical order. So from .booleans import, and we'll just pass in that class type to the classes, so that will register it. Alright, now in interfaces, let's go to the View 3D panel. And let's go down to where we draw the operators, and I'll just put in the booleans right here. KT boolean, I think I just named it boolean, KT boolean. Alright, so that will draw it, but so that we actually can change the settings, we'll have different buttons for each one. We can just override the text and do text. We'll say difference. And we'll just put in the three here, union and intersect, like that. Alright, this first one we'll say prop dot, and then we'll set it to the boolean type. So we'll access that property, and we'll assign it to difference. Alright. Do union and intersect. So let's have a look at that inside of Blender. Make sure our panel is right. K-Tools, difference, union, intersect. And we could actually draw this into a box to kind of separate it. So we could say box equals layout dot box. And then instead of using layout, we'll use the box. There we go. So it sort of has its own little area. And we could even do box.label, and we'll pass in the text, and we'll say booleans. like that. So now we have our Boolean section. Okay, so we need to go ahead and create a poll operator so that it can detect if we have everything selected properly. And the proper selection would be that you have one object selected and then you have another one selected as well. So two are selected, two or more are selected, and one of them is active. We'll call the active object the target. And there's a few context properties we can access. One of them is going to be c.activeObject. That'll be for the active object. And then the other ones could be obtained from c.selected editable objects. Alright, but do note that the active object is in here, so we can actually use list comprehension to get that. And I'll show you how to filter that out later. So anyway, let's go ahead and write in our function. So we can go up here, and I'm just going to make a new section called functions, and I'll create that function now. So I'll say def get target and booleans, and we'll pass in context, and you could do a type hint context as well. So what we need to do is access that variable. So we'll say first let's actually do a few if checks, because I want to use this in the poll. So that means we should make this pretty fast. So we'll say if not is, well, we can actually do if is. So we'll say if is instance context dot active object, and we'll make sure it's of type object, and context dot active object dot type is equal to mesh. All right, then we can say target equals context dot active object. For the next part, we need to get those other booleans, so we can say booleans equals, we're going to use list comprehension here actually. We'll say obj for obj in context dot selected editable objects if obj dot type is equal to mesh and obj is not equal to target. That will also, this part right here will make sure that it's not our target. So this booleans list, this list of booleans here should be all the selected editable meshes, but it's also going to filter out our target object because we want to have the two separated. So we'll say if booleans, just to make sure that there's objects in that list, we'll say if booleans return target and booleans. And then if all that fails, we'll say return none, none. So that way it matches our signature. And we could also specify the return type. We could say object and a list of objects, or this would actually be a tuple like this, tuple, or a tuple of none, none. That would be our signature there. So get target and booleans, you pass in the context, it returns back a tuple, object, and list of object, or tuple none, none. So we can come down here to the poll operator and say if, well, we'll just say target and booleans equals, and we'll pass in that context, and we'll say if target is none, I did not mean to hit that, if target is none or booleans is none, return false. Else it will return true. Okay, so it looks good, and we can actually just copy this part here and come down to execute and paste that in. So now we have our target and booleans. So what we need to do here is say for obj and booleans, and you could even name that boolean if you'd like. We'll just do that, and then we'll say for boolean and booleans, we'll do mod equals target dot modifiers dot new. We'll pass in the name, we'll say boolean, and then we'll pass in the type, which is going to be boolean. Alright, so that is our modifier, our boolean modifier. And now we can say mod.object equals boolean. And I believe that is correct. Let's just make sure. So let's set up that boolean real quick. And I'll go in here and do generate boolean, set our target, and let's just get that modifier. So say mod equals c.activeObject.modifiers and get the first one out of the list. And it's the only one, so that's it. Mod.object, and there it is. That's the other object there. Okay, so mod.object equals boolean. That looks good. So for boolean and booleans, so we set that. Now we can set the display type on this object, the viewport display here, to wire. Alright, display type is wire. So we'll say boolean dot display type is equal to wire. So let's check that and see how everything is working. I'm just going to create a new file here, and we'll just duplicate that and open up the panel here. So we'll select this one, then this one. This seems to work now. We could do difference, and there we go. But it's still not parented. And we also haven't moved this to a new collection or assigned the hotkeys. So there's a few things left to do here. Alright, let's work on parenting. So I'll pause this and create the parenting function. Alright, so I've created the parenting function. And so we're going to parent this boolean to the target. And this works by, well, first I'll just call the function so you can see which one comes first. We'll say parent object, and the child will be equal to the boolean object, and the parent will be equal to the target. Okay, and this works by going parent object, so you pass in the two objects. We'll just do a quick type check on the two, and then we'll say if child.parent, so maybe that object, I'll go back to Blender, maybe this object is already parented to something else, so we'll switch the parenting. So we'll say unparent child. That's going to check the object because these could be called individually, so you might want to call this in another area of Blender, or another area of your add-on or something. So I just type checked again there, but anyway, so you unparent the object, you just get the matrix world, you copy it, obj.matrix equals, or obj.parent is none, and then you say obj.matrix world equals that matrix. That way it will, set it back to the position that it was. And then in parent object, it will continue and say child.parent equals parent, and then you set the child's matrix parent inverse back to the parent matrix world.inverted safe. This right here will take, well, you just have to kind of know what that is. But anyway, I do cover it in the course, video link in the description. But okay, so let's look at, I think that will work. Now let's just go ahead and try that. Make sure I did do everything correctly. So I'll just create a new cube here, scale it down, and we'll just run difference. And if I move this around, everything looks right. And let's create a new file here and actually just check for shear. Anyway, always checking for distortions is a good idea. So I'll just parent this, and I'll put a cube right here. All right, and I'll subtract this. Well, actually, I'll make sure I skew this. And let's just try and do our parenting now. So we'll go in here, get it set up with the selection, and do difference, and it stays put. Now let's undo a little bit, and I'll check that if this thing is parented to something else. So Control P, so this is parented over here. So let's just make sure that this will unparent and reparent it to this one properly, and everything seems to be working. All right, so that's that. And I will move this stuff to some utility functions later. I might just keep this here because it's specific to booleans. I don't really see myself using this probably anywhere else. Unparent and parent child. So that works. Let me see what else we need to do. And we actually just need to go ahead and set the actual options here. Right here, difference, union, and intersect. So if you go to the boolean modifier and you just select it, it will show up. So I'll just copy these three right here, and I'll just paste them in, and then we can actually just go in here and remove this, cut that part, and I'll go up here. So we'll say mod.operation, and I'll just need to check the spelling. Intersect looks right. If you double click it and it's the same, it'll match it up. So I guess I spelled everything correctly. So mod.operation, and we'll just say self.boolean type. Boolean type like that. And also, it might be good to have the modifier be collapsed when you bring it over. So we can do this right here. We can say, I'll just do this at the top actually, mod dot show expanded false, just like that. And now when we go over to Blender and create a new modifier, so I'll just delete all this stuff. Let me get the cursor back to the world origin here. And if I select those two and do difference, it's not, already expanded, okay? And let's test this with multiple objects. So I'll shift select these, get that, and do difference. There we go. It's working as expected. Now, these are all set to exact. We could set them to other modes, but I'll leave them for now. Float is a little bit of a faster method. It's okay. We'll just leave everything to exact. And let's see, what else do we need to do first? You know what? We'll just go ahead and move these two functions here over to a utilities file. So I'll just give us a little room here, and I'll create this utility. I'll call it object.py, and I'll just copy over this imports portion, and we won't need this bmesh stuff. Not for right now anyway. We'll leave that. That looks fine. And I'll just go to booleans, and I'll cut this from here. Go to object.py, paste it in, and just give us a little bit of space there. Okay, so unparent and parent object, and then go to the init file in utils, and in alphabetical order I'll just import this. So from .import and say object. Alright, that looks good. So I'll just close that, and I guess I'll leave that open for now. And since it's saved to utils now, we can just go to use our utils. So utils.object.parent object, and we'll just pass in the same parameters as before. Alright, and that looks good. And I can actually put in a type hint on these, and it's just going to be object and object like that. Alright, looks good. And I'll close that for now, and I'll actually just go ahead and commit these changes. So I'll say booleans, and I always like to put WIP dash or something, whatever I'm working on if I'm not fully done yet. But I don't really do stuff on branches that often when I'm just by myself. I guess I should be doing that, but anyway. Let's continue on and see what else we need to do. Let's check the other boolean types as well first. So I'll delete all this stuff, add a cube in here, and let's just shift click that. So we have difference. Alright, that one works. And we'll do union. That one seems to work as well. So if we were to move this, well, if we were to bevel it, we can actually hide that object, hide those two, and that looks good. Let's try intersect. And that is our intersection. Okay, looking good. Now we could handle, let's see what else we can take care of. I think we can go ahead and do our collection stuff, so moving it to a new collection. And I'll give you a tip before I go and make these functions. There is going to be c.scene.collection, well, not .co, but collection, and that will give you the scene collection, okay? And what the scene collection is so we're in the scene, okay? This is the scene collection. It's the main collection to your scene, all right? And then there's also view layer, but we won't need to worry about that at the moment. So anyway, if you were to create a new collection, what's going to happen is in the blend file, in collections, a new collection will be created. All right, so if we do COLL for collection, we say bpy.data.collections.new, and we give it a name, and we'll just say my collection, like that. You can see it goes to the blend file, so my collection. Now what we can do is say col dot, well, we have the collection, and then we could do c.scene collection, well, collection, there we go, dot children, and then dot link, and we can link our new collection. So there it is. But another gotcha is if you do it 2 times, it will give you an error saying error collection, my collection already in collections. So what you could do is say collection.name. That will give you the name of the collection that we created. You can say collection.name, and we'll do c.scene.collection.children, and recursive. We'll say collection.name in, and it says false, which is a little interesting. So let's actually maybe not pass in name. Okay, so it's true. Some things you have to check by name, and some things you have to check by the actual data type instance. And in this case, we can check if it's in there. So that way, you know, if we're going to create this new collection and append it or link it to the scene collection, we'll just check if it's already there. And if it is already there, then we'll just return the collection, and we don't have to, you know, worry about linking it. So that's your little tip on that. But we'll go over here and create a new utils file called collection. I'll say collection.py, and I'll just go to some utility file. Actually, I'll go to object and just copy this, and we'll paste that in here. Now I won't need any of the math stuff for collections, but now what we can do is say def create collection, and we can pass in the name, and I'll just put pass for now. We can say def get collection name equals maybe something like this, and let's see, we might need something else like def link collection to scene, and we'll pass in, you know, the collection like that. We can import the type, so collection, and pass, so link collection to scene, and then we could pass in the scene. So we can also get a type for that. And let me pause and I'll fill these out. Okay, so what we have here is a top level function that somebody would generally call, like this is going to handle most of everything else here. So ensure collection in scene by name. So you pass in the scene and the name. It'll say collection equals get collection from scene by name. Then it will go into this function here. If scene, you know, do the type check for collection in scene.collection.children recursive. If collection.name starts with name, return that collection. Else it'll return none. So if that collection is already in the scene collection, it will return it. And it's just checking it by name and checks it to see if it starts with that name. So it could be collection underscore, it doesn't matter, whatever, as long as it starts with the name. So if is instance collection, it will just return that collection. Everything was found and it's good to go. Otherwise, it'll make a new variable collection. It'll just override it and say create collection. So it creates a collection into the blend data, and it'll create it by that name, and you get a reference to it. And then it would just say link collection to scene. So collection, and you pass the scene in, and then you return that collection. Then of course I make sure I import that collection. Okay, and then in the operator, I just do this right here. I go scene equals context.scene, collection equals utils.collection.ensure collection in scene by name, and we want to create a booleans collection, and I just printed the collection. So let's see if that works. So I have the cube here, and I don't have a booleans collection set up, and you can see the blend file just has this one collection in it. So we'll run this difference, and we get the boolean into the scene collection, and it's created one into the blend data as well. So what could we do to append our actual objects to it? Well, we need to go back to our collections here, and then underneath we'll just say def. Okay, we'll say append object to collection, and I'll fill this out and show you. Alright, so this is append object to collection, takes an object, the collection, returns true or false. Just do a type check. We'll say collection.objects.link obj. And if that happens, it'll return true, else it'll return false. And back inside of the actual operator, we could say utils.collection.append object to collection, and the object will equal the boolean, and the collection will equal our collection that we got up here, where we named it boolean. Okay, so this is the problem that's going to happen, is it's going to say that this is already in the collection. We'll just make a new blend file here, and I'll just expand some of this so you can see it. And here we go. Go into our tool here, and I'll select the two and hit difference. Everything worked great for the first one. Okay, so we created our booleans, we've assigned it, and there it is. Okay, but if we run it again, all right, which shouldn't be able to do that. You know, you don't want to create the same object, you know, twice. You don't want to create two Boolean modifiers pointing to the same object. We'll deal with that later, but hit difference and you'll get this error that occurs. It says it's already in the collection Boolean, so you don't want to try to add it back. Okay, if it's already in there, don't try to do it twice. So in this case, what we could do is say, we'll do if obj.name in collection.objects then we won't do it, but we'll say if obj.name not in the collection.objects. Let's see this right here in action. So we'll run it again, and everything seems to be good in this case. We'll try a new object here. So I'll select that one, difference. There we go. And let's just bring this to the top level here. And I'll actually delete these. And a lot of modifiers. Okay. So we have the cube, and then we have this top level cube here. So let's see what happens. Just testing things. There we go. And this is something to note, okay? An object can be in multiple collections at once. So what we would like to do, even if you turn this off, it doesn't, you know, we have this cube in the top level collection, and this cube is in the Booleans collection as well. So what we need to do is go into the scene collection and remove this object from all the collections and then append it only to this one. So we'll pass in an option right here to append object to collection to remove from other ones. So we could do remove, we'll check it out. I'll name it and everything and then we'll look at it, but basically I'm going to say remove from other collections. If that's true, we'll go into this object and remove it from all the collections in the scene and then just add it only to this one. Okay, so let's take a look at this. So remove object from scene collection. You pass in the object and the scene. Just does a little type check, and it says if obj.name in scene collection.objects unlink obj. So that right there is if the object, okay, so is at the top level, so it's in the scene collection. Okay, if it's in there, we're going to remove it from the scene collection. So this is what this part is all about. And then from there, we're going to get scene collection. So all the other scene collections, like this one, it's going to get all of them recursively and go for collection in obj.users collection. So if you have an object and you say c.activeObject, you can get the users collections like this, and it will return back all the collections that that object is in. But you don't want to remove them from all of the collections, okay, because it might be another scene somewhere, okay. So anyway, you know what I'm saying. So you don't want to remove them from all scenes. You just want to do it from this scene. I guess you could check the scene name matches the current context, but anyway, I just wanted to check that. So because you can have collections that are in other scenes, so it's just safer to check the scene, see if that collection is in the scene, and then if it is, remove it. So for collection in obj.usersCollection, so we're just looping over all the collections that the object is in. If collection is in the scene collections, collection.remove. So we remove it from the main scene collection, then loop over all the collections that the object is in and see if those collections are in the current scene. If they are, then we do collection.objects.unlink. Alright, so we just call that right here, utils.collection.remove object from scene collection, and pass in the boolean and the scene. Then we append to the collection, alright, that we actually want. So we remove it from all the collections in the scene, then append it to the one that we actually want. Then we just do the parenting, and then set up the boolean modifier, and then set some boolean settings, some boolean modifier settings. And this actually, we could move this up right here as well, just so that it's the display, and then we do all the modifier stuff kind of together. So let's just check that everything is working. Alright, so this boolean is sitting on the top level, and in collection is the other one, so this main target. So we'll just try this out, difference, and you see it created the boolean collection and put the cube in there. What if we were to say, let's create another object like this, and let's move it to the regular collection. So we have this one here, and we'll just do the difference. Alright, that seems good, and let's actually run it again with this selected. Make sure there's no errors. I think everything looks like it's working fine. Now, what if we were to say, what if we did, we already had it in there. So we already have it in there, in the boolean, so we'll just do difference. And it seems to be working fine there as well. So I think we've got the collection part settled. Now, we can actually create a little function here to add the color. So, you know, ensure scene by collection, and we can actually set the color if we'd like, and so I'll show you how to do that. Alright, so I created this little section right here called types, just for like classes or whatever. Then I made this class called colors, and I inherited from enum. You just import that. It's just a class type, and it allows you to, you know, create these data classes like this. But this is the function, so color tag collection, you pass in the collection and the color, and it should be of this type right here. And then I just did a little type checking, and then I do collection.color tag equals color.name. So it'll be the actual name, like color 01 and so on. That's what this is going to do. Just give the color tag, or assign the color tag to the color.name. And I'll show you how to use it. So I go back to the booleans operator, and I did it right here under the collection where you get it or create it or just, you know, ensure it. And then utils.collection color tag, and then I just pass in the collection. I do utils.collection.colors and .color01. And I put the comments here, so that's going to be red. You could do orange, for example, and I could just put in orange like that. And I already tested it, but, you know, so it's red right now. So if I run this again, it will turn it to orange. And let's go back, and I'll just do color 01 for red, and there you go. If I run it, that'll create it red. Now let's look at this last problem before we set up the hotkeys, which is if you keep running this, it will just keep adding, you know, another boolean with the same object. So we just need to loop over all the booleans and, you know, all these boolean modifiers, and make sure that we're not about to duplicate anything. So what we could do here is under booleans, let's just under this spot, let's just go ahead and remove the booleans that are already there in the modifier. So we'll just say for mod, well, we can actually, yeah, that's fine. For mod in target.modifiers, if mod.type is equal to boolean, and then we'll say if mod.object, obj, or well, object, same as we did here. If mod.object in booleans, we'll do booleans.remove mod.object. Okay, so that will remove it from this list. And then if it doesn't do anything, like if there's nothing left, then we could just say boolean, well, we could say if not booleans, we'll just return canceled, like that. That way it doesn't save anything like into the undo system if it didn't even run. So let's try that, and nothing runs this time. So let's try adding another one, and we'll create that one, but it won't do it again. Okay, so let's just create a new file and just test that everything seems to be working properly without so much clutter. So I'll just select those, select the last one, and then do KTools and then difference. And there we go. Now you can actually turn this off. And we might need to actually check that as well with the collection stuff. So if I do this, difference, let's make sure it goes in there. And it did go in there. Let's see. If I turn, let's turn all of our filters on just to make sure this is going to work. So I'll turn all those off. And let's go ahead and do a difference. And there you go. It's in the collection. Now, if anything comes up, I'll fix this. Sometimes this is called exclude. See that little Python tooltip? Sometimes you have to check that in different scenarios, like when you go to, modify stuff or, try to append something, it'll say that collection is not in the scene because it's got the exclude flag. But I don't think we encountered any issues with that on this go. But I think that does it for this. So let's go ahead and look at those hotkeys now, and I'll just create a new file. And let's go into our registration here, and we'll say we'll just do a spot for this. We'll just do hotkeys, and then we'll just go in and work on adding our hotkeys. So we'll say def register hotkeys, and I'll put pass, and then I'll just do unregister hotkeys. And make sure you call this last inside of this portion. So register hotkeys and unregister hotkeys first in this one. Okay, so just make sure you have that. And then I'm going to create a global variable here that will stay live while the add-on is loaded. And I'll just call it keys like this, and we'll load in all of our keys. So what we need to do now is get our key configuration. So I'll just say kc equals, and then we'll just do bpy.context. Well, we need to import bpy in this case. So I'll just go right to here and import it. That's okay. Import bpy. Okay, bpy.context.window manager. That's where all the keys exist. Key configs, that's where the key configurations exist. And then you can do .addon to get the add-on configurations. And then we'll create a key map, and we'll say key map equals key configuration dot key maps dot new. And then we'll give it a name, and we'll call the name object mode like that. And then the space type, we'll assign it to empty. Okay, so we can create now a key map item. So KMI for key map item, and we'll say key map dot key map dot key map items dot new, and we'll have to pass in a few things here. I'll just copy it from here. This is from the other add-on that I have. And this will be, okay, so I put kt boolean, so numpad minus press, and you have to hold shift, so, or actually control. So control numpad minus will launch this operator. Now, remember in our operator we have this boolean type right here. We can actually access that from the key map item. So we do key map item dot properties equals key map property dot items dot, and then the name of the property equals, and then we pass in the value, which is going to be difference. So if I save that, let's just make sure it works. So I'll go back to Blender and control minus, and there you go. So now that works. So what about the other ones? And also I make sure that I append this right here. keys.append keymap and keymap items, and just make sure that you clear this in unregister like that. So keymap item, because that's what we appended, and you just loop over the keys that you have saved, and then you just remove that keymap item from that keymap. Okay, I know it's a lot to say, but you just need this to unregister the keys. So what if we do another one? And for this one, instead of numpad minus, we do control or numpad plus. Let's see what it would be. I think it'll give it to us. Numpad plus right there. And this will be the union one. Like that. And let's check that that works. Control plus, and there it is. We have our union. And then the last one, we're going to do control / I think it's numpad slash or intersect. Let's do the intersect as the asterisk. So we'll do that one like this, numpad asterisk, and control is required, but the others aren't, and this one's going to be intersect like that. Okay, so let's save it and go back and try it. So this one is going to be the intersection, and there we go. Okay, so the intersection is set up. Okay, I believe that is it for this one, but also one last thing, there's this operation called slice, and a lot of add-ons have it, and so we can actually try to implement that as well, and I'll show you what it is real quick. Okay, so this is the effect of the slice operation, and well, let me show you how it works. So if you take the target copy and just hide it, well, this looks like a regular difference, and it is. So you have your boolean here, and then you have your regular target. So you're just subtracting that geometry. No big deal. So how do you get that little piece in there? Well, what I did is I copied the main target and then did an intersection with this boolean. So if I hide the main target and reveal the target copy, well, that target copy has a boolean, but it's set to intersect. So that gives you that little piece there. So on the main target, you subtract the space with the difference boolean, and then you copy the target, and then on that one you would do an intersect with that same boolean. Okay, so that's how you can create this effect. And so to program it, it requires a little bit more work, but I'll just show you that as we go. But yeah, you just need to be able to copy this main target and then do an intersect with the original boolean, and then on the main target do a regular difference with the boolean. So the boolean goes to two modifiers. It goes to the copy for an intersect, and then it goes to the target with a difference, and that will give you this little piece in there. And the cool thing is you can go to the copy version and bevel it or something, and it will update the little piece in there because you're just getting the intersection. So if I was to hide this target and then reveal the target copy by disabling this modifier, you can see this is what we're getting an intersection from now. Alright, so hopefully that makes sense, and well, let's get in and try doing some coding for it. Okay, so I'll show you what I did, but let's just test this real quick. So I'll select the two objects here and then hit slice, and we have the cube gone to the booleans collection, and then we have the other cube, which would be our target, and then we have that copy right here as well, which is the little piece. And everything is parented properly, and yeah, looks pretty good. And there's room for improvement as well. And I also set these to show in edit mode as well. That way, like when you go in here, well, on a standard operation, let's just do like a difference and difference. That way, when you go to edit mode, it will show this. I also enabled that as well. There you go. Yeah, so let me show you what happened. So it's quite a lot, but the top portion right here is about the same, but then we just added in this operation slice right here. And so if it goes into this, what we do is get the target collection. So that is the target object. And I said get probable collection because it has to be visible. You know, you have to make sure that when you go get a collection off of an object that the collection you're getting isn't excluded. So I'll show you the function. It's a little tricky, but you can kind of read through that if you would like to. It's probably could use a little improvement, but it's pretty close. So anyway, we'll go back. So it gets the target collection, which all I'm trying to do is get the collection of the object, the target. I'm just trying to get the collection, which is this. I just was doing some view layer stuff to make sure I didn't, get a collection that was excluded like that. Because, one object, because an object can be in multiple collections at once. So you don't want to go loop over all the collections. Oh, it's in this one, return it. And it might be one that's not even there like that. Or not visible or something, which I don't even think I checked for visibility, but I just checked for excluded. So anyway, we get the probable target collection. And then if that didn't work, we'll just get the context.scene collection. Just the top level scene collection right there if we couldn't figure out what collection to use for the target. And that's like a little fallback, and that's fine. So then what we do is copy the target, okay? Just like we showed, you have to copy the target. So I'll show you duplicate mesh. So it just does a little type check, make sure it's a mesh. And you just do make sure, well, this right here, if obj.data is edit mode, this is if the object is in edit mode, just to flush the edit mode data to the object data. Okay, so you just can do a little check there. And all I did was say copy equals obj.copy, so it copies the object. Then we copy the actual mesh data, and then I cleared the animation data and returned back the copy. Alright, so we have the collection, a copy, and then we just do the parenting. So I just made sure the copy was parented to the target. And then utils.collection.append object to collection. So we took that collection that we tried to get and made sure that the new copied object was in there. And then we just set up the boolean. So we say copy mod equals the copy object, modifiers new slice, and then we just set up the intersect and difference. Alright, so that's slice. And then otherwise it would just do what it was doing before. And then I also made sure I set show edit mode equals true. So there's a lot that went into that. There's a lot that happened, but essentially that's pretty much it. And of course all the code is on the GitHub. It's just KTools on GitHub. The link is in the video description. And also we could set up the hotkey real quick. So we'll just go right here. And we'll set this to, let's see if we can get the IntelliSense to work. So numpad, and then it should be slash, numpad slash, and then we'll set the type to slice. So let's go over here and see if that works. I'll just make a new file. So let's bring this up, and then numpad slash with control, and there you go. Alright, so for the last thing we're going to talk about in this video, I'll just show you the shading. So I'll just maybe do something like this, and it's shaded flat. So you can see it's faceted. Now, if I was to just add a cube in here, and we're just going to do a slice, something like that. All right, if I do a slice, control / on the numpad, boom. All right, so it has the faceted look as well on these objects. Well, what if I did another one? But this time, before I did the operation, I said shade auto smooth. So now it has smooth shaded the object and then applied this auto smooth feature. So let's go ahead and try it now. And you can see that it shaded this smooth as well. So how you do that would be to, before we start the for loop, I just said shade smooth equals utils.object any polygon shaded smooth, and I passed in the target. So we just checked if the target was shaded smooth, this one. And we just stored it into a boolean. Then inside the for loop, we say if shade smooth, utils.object.shade polygons, and we just shade the boolean to be smooth as well, okay? And I'll show you these two functions. And you can see right here, any polygon shaded smooth, so this is what we pass the target into. And if it's in edit mode, we just flush the edit mode data down to the object data. Then we say for polygon and obj.polygons if polygon.useSmooth, and we just, if it is, we just return out and say true. Then to shade the polygon smooth, all we have to do is pass in the object and whether or not we shade it smooth. Then we just get the mesh data, and then we say if is edit mode, then I create a B mesh and get the B mesh from edit mode. I loop over the faces and set it to the option passed in. Then we update that B mesh data, and then we update the object. Then if it's not edit mode, okay, so mesh is edit mode is false, we'll just go through the polygons data. So for polygon obj.data.polygons, polygon.usmooth equals whatever this is, usmooth. So that should set that up pretty good. And of course, you could also go in there and automate adding the auto smooth modifier to the booleans as well, but I'll save that for another day. And I think that's it for this video.